Next, I'd like to introduce a gentleman who runs a company that you may know by the name of Machine Zone. And it's actually rebranded as MZ. And it's taken really sophisticated technology that it generated for its very successful Game of War, and introduced it for a whole new set of applications, its back-end technology. And he's going to start talking about what he's doing here and demoing it for the first time. So I'd like to welcome Gabe Leydon to the stage, please. Thanks. Okay.
Thank you. Thank you.
So I understand you have a presentation.
Yeah.
Thank you.
Hi, my name is Gabe Leydon. I'm the co-founder and CEO of Machine Zone, or MZ. And what we're here to present to you today is what our vision for a smart city is. Machine Zone is famous for these. You may have seen these all over TV. Our Arnold Schwarzenegger ads, or Kate Upton for Game of War and Mobile Strike. These are very large games. What people don't realize is they are the largest concurrent video games on the planet. We are built to handle millions of players in one single simultaneous real-time environment. And that technology that we have been working on over the past 5 years, we have decided to adapt it into a platform. And we came up with this really cool project. So what we call it is RT Platform. So RT Platform is three things. RT Platform is a massive messaging processing system. We can process hundreds of millions of messages per second on a single channel. To put that in perspective, NYSE peaks at around 8 million messages per second. So imagine having around 300 million chat messages going into a single chat room at the same time. That's what we're able to do. We're also able to run real-time search queries into this stream. So imagine these 300 million messages coming through this flow of data, and you want to write a very complex search query and get an instantaneous response, print your graphs, see what's going on. So you can search through this data very quickly, and because you can search through it, you can also write an intelligence layer on top of it. So we've got this huge system that's processing tons of data. We can search through it instantaneously, and we can give it commands back with artificial intelligence. So it's the numbers that we are currently pushing are so big that you kind of need to come up with a project that shows off what this can do. So what we came up with is we are going to run a country in real time instead of a game. All right, so we came up with this idea to network the entire public transportation infrastructure of New Zealand in one real-time application. It's kind of this crazy idea. There's tens of thousands of buses in the country. There are millions of people that use these systems in a monthly basis. And we have the capacity to be able to run this entire system in its digital infrastructure in real time. And the shocking thing about it, it'll only take about 1% of our capacity to do this. So the first application that we built, which should kind of look familiar to you, is a consumer application that's coming out in the next couple months. It's an iPhone and Android app that'll allow people to find out where their bus is. Pretty straightforward. So let's kind of just go through that. So we're trying to get your 5 minutes back. Anybody who grew up using buses, I'm 36 years old, so when I had to wait for a bus, I would show up to my bus stop 30 minutes ahead of time because I had no idea when it was going to be there. This is gone now. So now we're just clicking on bus stops. We're seeing the next one comes in 8 minutes, two alternative routes. I can see I've got the next one in 8 minutes or 14 minutes. I can walk directly to the stop right when it gets there, no more waiting. So pretty straightforward. You might think this looks kind of like Uber. What's the big deal? Let's get into the bigger part of this, which is the command center.'t not only do the citizens have a total real-time view into their public transportation system, so does the government. So this is the Auckland Transport Command Center. This is a real-time view into their entire public transportation infrastructure. As you can see, this is Auckland. Right now, there's about 630 buses online and about 9% capacity total people on the buses right now, roughly around 4,000 people riding buses at the moment. This is downtown Auckland. We can select routes, get a real-time view of where every bus is on the route, whether they're on time or not, the individual capacities, so on and so forth. In the city of Auckland, there's about 3,000 buses, and they're managed by about 12 different agencies. We're also able to run kind of a real-time high score table between those 12 agencies, so we can get better efficiency. If you're managing these 12 agencies, you want to know what they're all doing. So now we can look at all of the routes. I can see where my capacities are. I've got routes with 0 people on them. I've got agencies with 143 errors. So I have a lot of work that I need to do in order to manage the system. Auckland had never seen anything like this before. They're now running, this is currently live right now, they are now running their entire system in real time. This is totally mind-blowing for them. They had no idea what was happening with their ecosystem. Now they can see the entire thing. This is an example of a real-time SQL query into that stream itself. We can write extremely complex queries onto this stream and get instantaneous results. So here's just a couple of examples of sorting this feed by agencies and by routes. So once you've got all of this kind of analytics infrastructure, the final step is a bot. So here's an example of an error detection bot. So as you can see on the right, there's a group of errors there, but the top one says out of route. There's about 90 buses currently out of route. What that means is around 15%, usually around 20% of their buses at any one moment are not on the correct route. As you can see right here, this guy is, I don't know, a couple miles off of his route on the freeway right now. And that red line is supposed to be where he is. So this is all done through a real-time detection bot that takes the
Gabe, to be fair, if this is live, what time is New Zealand right now?
yeah, I'm a little early. So we have the database of where all the buses are supposed to be, and we have a bot that's monitoring their GPS location and their time to alert the Auckland Transport Authorities exactly where the bus is so they can make a phone call and eventually just get an automated alert back to the driver to tell them to get back on course. So to give you an idea of just how big of a problem this is, when these buses go off route through your electronic tickets, you get double charged right now. So the automatic bus system thinks you're on 2 different buses because your bus went off route. That's currently how it works. So Auckland Transport gets hundreds of emails a day from users wanting refunds. All of that's going to get solved now because we can automate this system in one place. So now that we've kind of got this, the entire digital ecosystem networked, we can read it, we can write to it, we can put artificial intelligence onto it. Now let's talk about automating the experience. So here's an example of what it's going to be like to go to work. Instead of talking to Pizza Hut when you want a pizza, you're going to talk to the city itself. And it's going to know from your calendar when you need to go to work, and it's going to suggest to you which buses to take, what bus stops to go to, and exactly when you need to leave to get there on time. We're going to be able to look at traffic congestion and be able to plan your day completely based on what's actually happening in the city as it's happening, instead of some kind of search or Google Trends. This is a real-time view into what's really happening. So we wanted to elevate the conversation here a little bit because I think the bot conversation gets sidetracked into this concept of like ordering pizza, or it's kind of a personal assistant. I think bots can actually go much, much further than that. I think bots are going to be running countries. There's a lot that we can automate once we network all of these endpoints together. And right now, when people talk about IoT, they talk about devices, not the networking infrastructure. So we're providing the platform that enables hundreds of millions of devices to be able to talk to each other in one many-to-many network.
Awesome.
Thank you.
Thanks, Gabe. So so that little joke of mine about what time it was in New Zealand, Gabe actually wanted to show this live and is able to, because I've actually seen components of it. But because of the venue, because this is one of the first sessions, we wanted to actually have it recorded. So he spoke along a recorded version. So what time was that? It was probably midday somewhere.
It's like 4 in the morning.
No, but in terms of when that was reported,
that's
actually
in the morning.
Yeah, it's actually real. There are high percentage. That was one of the things that surprised me. There's a high percentage of buses that are off route.
Well, you wouldn't know that,
Yeah.
right? So how it currently works right there before the system is the agencies would self-grade themselves. So every quarter, they would give themselves a report card about how well they were doing, and they would get a bonus based on how they graded themselves.
Yeah.
Okay. So now that there's proper reporting, proper digital infrastructure, and soon there'll be infrastructure for the citizens as well for them to interact with this system in real time, the level of efficiency that's happening because of this is not trivial. If you were to pitch it and say, oh, I'm going to build this map and you're going to see all these buses, you would think, oh, that's no big deal. What am I going to do with it? When you put a layer of automation on top of that data, you're able to create a level of efficiency that is maybe 20, 30, 50x bigger than what you thought you would get out of tools like this.
Yeah. So on VentureBeat, we reported the early version of this when you were planning and you were telegraphing that you had this deal with New Zealand. But can you help us catch up to speed in terms of what's live right now? Because there are lots of that, and I'm just wondering.
So the command center, the command center is live and being used right now.
Right now.
Right now.
Okay.
Absolutely. Right now. And the mobile application is coming in the next 2 months for the citizens. So once the citizens get the application, a couple million people ride the buses in just the city of Auckland, they will also be involved in that digital infrastructure. So now you're going to get a kind of real-time anonymized view of how long are people waiting for buses? How far do they have to walk to get to buses, right? So a total digital view into the entire ecosystem that can all be automated.
Got it. So it's too early to talk about some of the findings on the bot because that actually hasn't been released yet, right?
Yeah, it's too early to talk about that, but the few automation bots that we've built for management have already changed the way that they're running the city.
Could you talk a little bit about? I mean, and I know you've been skeptical on the bot phenomenon and hype in the valley, because you seem to each time we've talked about it over the last couple of months, you said forget the pizza bots and we're doing something more meaningful. And can you talk a little bit about what you foresee as the bots that you can produce that are meaningful?
Well, what RT platform represents is a gigantic jump in networking.
Yeah.
We can network hundreds of millions of devices together into one real-time digital channel of data.
Yeah.
We can search that instantaneously, and we can write rules to it instantaneously without a database. This all happens live and in memory, okay? So your ability to work with extremely large systems is going to change. Because right now when you look at the internet, you don't think about interacting with hundreds of millions of devices.
Yeah.
And that's what Game of War really represented to me when we made that game. I wanted to make a game that everybody around the world could play together at once from their phone. So if I'm in Russia or Japan, they are interacting with each other as fast as we can get it to happen. That level of networking infrastructure is going to be available to everyone soon. So when you think about sensors and mobile devices all being able to communicate with each other in real time, and then being able to put analytics and artificial intelligence on top of that, something like running New Zealand, you don't just do their buses. This is just the beginning. You go to their electric grids, you go to their hospitals, so on and so forth, because you can handle the volume.
Right.
It's possible now.
Yeah.
So you won't just be running transportation from that, you'll be running everything from it, and you'll be automating as much of it as you can. So the pizza bot, and that's what I'm calling them, like the pizza bots,
yeah.
Those are really great tools for like personal assistance kinds of thing, and that's where they're thinking about it right now, because just interacting with just my data, the questions I ask it.
Right.
The bots of the future will be interacting with all of the data and making decisions based on everything that's going on, rather than just what you and I are doing individually. And will create a totally different society than one that we're even thinking about right now.
Right.
Because you're going to have network computers that can talk to billions of devices at once. And they're going to be able to make decisions instantaneously.
Right.
So that's happening now. That's not happening a couple years from now. That's happening today. This is possible today. So this kind of platform, I think, could have pretty profound effects on the world.
Yeah, I mean, so in terms of comparisons, this is an ambitious project. You've talked about the public transportation system having parking and traffic lights involved, and then eventually maybe even going further afield, right?
Anything.
All
We think about like how we want to be able. How I see the internet is to me the internet's broken. It's not a network. I just ask it a question, it gives me a response.
Right.
It's not acting like what it should be acting like, which is a connected network. There's 3 billion people online right now, but you would never know it. And where would you go on the internet to feel that even, that there's 3 billion people online?
Right.
That's what my games try to do, is try to expose you to the totality of the internet.
So Gabe, what other precedents are there that match this sort of ambition in terms of the New Zealand project, right? So I'm aware that Singapore, for example, is the city-state that does a lot of intelligence on a network. Can you talk about comparisons?
So the difference is, I mean, unfortunately, it's hard to compare to cities. It's the fathers of this are video games, like EVE Online, Game of War, Second Life, where they were trying to connect tens of thousands of people together in one virtual environment. So you could do the same thing with the city. Instead of people, they're just devices and sensors, and we're trying to connect them into one large virtual environment that developers can write artificial intelligence on top of, right? So instead of Facebook being the platform, the city is the platform. The feed of the city, the feed of the country is the platform, and developers write to the country itself.
Right.
Of the data that's happening inside the country, and you write decision-making tools on top of that fire hose from New Zealand or from the United States or from China. Because that's where I think everything's going. So you're going to have development APIs that give you access to hundreds of millions of devices, and you're going to be able to create an interaction with those. Right now, even right now, it's book a hotel room, right?
Yeah.
What if I want to change the state of 1 million devices right now? Right. That's you have to think about. I want to make every stoplight red instantaneously. If I have some kind of emergency going on,
right,
I can do that. Or I want to change every parking space to free now.
Yeah.
Right. So you have to think about the world as a fully networked, interactive, kind of digital mirror of what's happening in the real world.
So you're talking very much, and I've heard you talk before about this being a macro bot, right? And Chris Messina, one of the early thinkers here on the bot side, has talked about microbots being really efficient, because bots can be most useful if they are focused on a specific niche in many cases, right? Because the user doesn't know
there's all kinds of use
what the limits are.
There isn't some master.
And and the limitations of Amazon and Siri are that they've got so much. Like how do they actually channel it? Can you talk a little bit about that challenge in terms of?
Well, this is this platform built for macro bots. That's the point. It's not trying to solve something that's already been solved. Smarter Child solved this 20 years ago. We just saw it, right? Or 15 years ago. We're trying to solve a new problem, which is I want to put a bot on the whole world and have the entire United States public transportation infrastructure live on a map, and have developers in this room write applications to it, right? Or the energy grid, or the hospital systems, right? So it's just a different way of thinking about networking.
And those various entities would have control over the API, right?
Yeah, I mean, there's all kinds of
SDK, right?
We're going to get into all kinds of legal and ethical and all kinds of those things are going to come up. But the reality is, and I don't have the answer for all of them right now, but the reality is that the technology exists today. This is not something coming tomorrow. This is something you can do right now.
Right. Could you talk about one or two of the surprises? We only have a minute and a half left. One or two of the surprises or things that you've learned with this project that you maybe were not aware of.
Well, this is how we work. This is how we run our games. Yeah. We're taking our own kind of internal workflow of this real time. We're like high frequency traders. We make decisions really, really quickly based on, we're very large marketers. We run a very large game. We're making decisions constantly based on a lot of data coming all over the place, and we're constantly changing our making new decisions all day long. Our staff is 24/7. So we work differently, and that workflow applies to a lot of other things. That also applies to a public transportation system, for example.
Right.
It's pretty much the exact same framework, just presented differently.
So you were able to carry it over. So there was no real surprises in that transition.
No. What I guess the only real the pleasant surprise was seeing the same response back from a different system. That working fast and working instantaneously actually makes a really big difference. But another thing I want to say is I joke about this, but we're constantly worried about like robots replacing McDonald's workers. Like these poor McDonald's workers are going to get taken out by these burger flipping robots, right?
Yeah.
I think we have a good opportunity to take out politicians with robots instead. Ooh. So I think I think a lot of government infrastructure and a lot of things that aren't really ran as efficiently as it could be run through automation, and it's going to take systems like this in order to do it.
Awesome. Well, we're almost out. So wow, they put we're minus 15 seconds.
All
right, Gabe. Thought we had more time. Thank you very much.
Thank you.